Welcome to whole numbers, integers, and equality. A lot of this stuff you'll probably know already, but we're going over it just in case. This is for Algebra 2. So first up, it's natural and counting versus whole numbers, and it's really simple. Natural numbers are also called counting numbers. They're interchangeable, and they're the set of positive integers beginning with 1 and they go on to infinity. So, like you would normally count, 1, 2, 3, 4, 5, 6, and so on. If we add one number, 0, to this set, we get the set of whole numbers. So the set of whole numbers is just one number larger than the set of natural numbers. 0 is the smallest whole number, and obviously there's no largest whole number because it goes on to infinity. Then there's the integers, which is a bit bigger. The set of integers is the set of whole numbers and their opposites, and this includes 0. Numbers greater than 0 are positive, and obviously numbers less than 0 are negative. And every integer a has an opposite negative a. The opposite of 3 would be negative 3, and it's the same for negative numbers too. Negative 3, the opposite of negative 3 would be 3. This equation here is called the additive inverse property of a. A plus negative a is 0, and this means that if you add a number and their additive inverse, in this case negative a, it would equal 0. So as an example, the additive inverse of 9 is negative 9 because it's the opposite, and if we plug that into the equation, 9 plus negative 9 does equal 0. And this works with negative numbers too. And there are other basic properties that you've seen since elementary school, and yeah. So I'm just going to skim over this. Addition is commutative, associative, it has an identity, 0, which means that if you add 0 to any number, it is that number, and addition's closed, which means that in the set of integers, if you add a plus b, it is also going to be an integer. The only function that isn't closed, I'm sure, is division, because if you divide two numbers, it isn't necessarily an integer. Now we get into absolute value. This is interesting. Every integer a has an opposite negative a, and although they have different values, they are the same distance from 0 on the number line. They have a distance a from the number line. When this distance is written as a positive number, it's called the absolute value of that number. There is no negative distance from 0. That's impossible. So absolute value is expressed between vertical bars, two vertical bars, like so, and 5, for an example, is 5 units from 0, so the absolute value of 5 would be 5. But negative 5 is also 5 units from 0, so the absolute value of negative 5 is also 5. Now we're going to get into some equations. So let's look into that equation right there. 2x minus 3 is 15. The domain of an equation are all the values that can possibly represent x without being undefined. In this example, it's all real numbers. An example of a domain that isn't all real numbers, there has to be some undefined, is let's just say 2x, let's just say 3 over x plus 1, like that. Then if x was negative 1, the denominator would be 0 and it would be undefined. So that would be, the domain of that would be all real numbers except for negative 1, excluding negative 1. just as an example. Anyways, moving on, a number from the domain that makes the equation true, in this case 9, is the solution or root of the equation. Now, how we actually solve an equation is that we set up a series of equivalent equations to the original one until the solution to the equation is evident. What that means is, if we go back here, 2x minus 3 is 15. This is the original equation. If we add 3 to both sides, we get 2x equals 18, right? This is just an equivalent equation, but it is equivalent to the original one, but it is just a bit altered, and we keep doing that. For example, if we divide both sides by 2, then we'd get x equals 9, which is also an equivalent equation, but in this case, the x equals 9, the solution or root is evident. So that's what we do. We set up a system of equivalent equations, and to do this, we use properties of equalities that we've been using for years without knowing their technical names, but that's okay. And those are the properties. I'm just going to skip it. You can pause. So yeah, we're done. Now, how these videos are going to work, they're not always going to be like these slideshow based presentations. The next video is going to be on drawing software, where I actually go over adding, subtracting stuff, actually doing math. Yeah, and but depending on time constraints, I might not do these presentations because they take a while. So if only if there's like it's wordy material and I need to make a presentation, I'm going to, but otherwise I'm just going to go over it on drawing software. That being said, expect a video soon. Thanks guys for watching.